Hello everyone, welcome to today's session. Today we are going to discuss about vectors. We will discuss them with respect to application of vectors in electromagnetic fields. What is electromagnetic field? Electromagnetic field have four components. First one is electric field intensity. It is denoted by capital E. Next one is magnetic field intensity denoted by capital H. Third one is electric flux density denoted by capital D, and the fourth one magnetic flux density denoted by capital B. As these are vectors, a bar on the head of these alphabets is shown. These are nothing but the mobile signal we get from an antenna. These signals have two parts. One is related to electric field intensity. It is a vertical sine wave, and another one is horizontal magnetic field intensity component. In physics, there are several types of quantities. They are divided into scalars and vectors. Scalars are those who have only magnitude, but they don't have the direction. Vectors have magnitude as well as direction. So electromagnetic wave is combination of two vectors. Hence, it is a vector quantity. Now, scalar, as we have discussed, the examples of scalars are time, mass, volume, pressure, density, potential. Along with that, one more example is speed. Usually, we get a question the difference between speed and velocity. Speed is a scalar quantity, whereas velocity is a vector quantity. So in scalar, the quantities which are mentioned, they have only magnitude, but there is no direction. We cannot say that time is going in particular direction like south, north, east or west. If I say that there is 10 kg mass available at particular place, but it doesn't specify that it is going to any particular direction. So such quantities are called as scalars. Normally, we are dealing with potential and voltage as application of scalar. Voltage is a scalar quantity. It has magnitude but there is no direction. Whereas vectors have magnitude as well as direction. The examples of vectors are force, acceleration, electric field intensity, magnetic field intensity, and their densities. So we have an electromagnetic wave where we are dealing with vectors, and the vectors are operating in space. That is nothing but a three-dimension place where we come across three axes. One is z-axis, second one y-axis, and third one x-axis. There is a particular direction of journey of propagation. On particular line, the vectors will travel. So it's all about the vectors crossing some particular space, crossing some particular medium. So this example is showing that the magnetic flux lines are crossing a given place, given surface or given plane. The surface is denoted by ds. Now let us define the vectors mathematically. Vectors have magnitude and direction. So vectors are given as magnitude into direction. If my particular vector is called as dl, so if I write a bar on the head of dl, it will be termed as vector. If I write simply dl, then it will be called as scalar quantity. These two things will differentiate the scalars and vectors while writing in mathematical form. So vector is equal to product of magnitude and direction. AR cap is showing direction here. Mod of dl bar is showing magnitude. So all the vectors will be given in the form of magnitude into direction. In space, how many possible directions are there? Spatial vectors or the vectors in space uses any three coordinates. If we talk about Cartesian coordinate system, there will be three axes. So we can find out place of any given point or vector by taking their distances in three directions. Say we will have I, j and k. So my vector may be moving in two directions or three directions. So these I, j and k are termed on x, y and z axis. So vertical axis will be z. A vector coming towards you we will consider as x and the remaining one as. These vectors are working in space. A space is place where we consider three dimensions. By using three dimensions, we can express any place in space. There are three axes. One axis is considered as, say, x-axis. Next one will be z-axis and the third one will be y-axis. The vertical axis we will consider as. So along with magnitude, we get direction in these three directions. Direction component is given by ax, ay and az. It is also written as ax bar, ay bar or az bar. In few textbook, it will be written as ax cap, ay cap or az cap. But ultimately these are the directions. So how can we find out unit direction? If vector is nothing but product of direction into magnitude, then we can say that direction is equal to vector upon magnitude. So it can be given as ar cap equal to vector divided by mod of vector. Magnitude is nothing but the length of the vector line. And unit vector is used to give the direction of a vector. So if we consider a 3D system, then we have to consider three directions. For example, we have x, y and z as three components, then their directions will be given as ax cap, ay cap and az cap. So here we can see we have two directions here. So we are considering two-dimensional system where one is ax cap, another one is ay cap. There are few dot product rules of direction components. We have to remember them. If we take dot product of similar direction components, it will become 1. So if I take ax cap dot ax cap, I will get 1. If I take ay cap dot ay cap, it will also become 1. But if we take dot product of different unit vectors, then it will become 0. If we consider third direction, that is say az cap, then we have to imagine this system for three directions. So az cap dot az cap will become 1. If az cap will be multiplied by any another direction, it will give result as 0. There are two concepts of multiplication in vectors. One is dot product, another one is cross product. Today we will focus on the dot products. Say we have to find out position of point P in space. If it is a two-dimensional space, it will have two components, one in x direction, another one in y direction. So if these two vectors are given in two directions, then the resultant vector will be addition of these two vectors. So let us see them in detail. If we have to find out a point P in 3D space, then the length of point P will depend on x, y and z component. So about ax cap, ay cap and az cap, we have to remember that these are nothing but only directions. If force is our vector, then it's all about how these forces are applying their effects on given points in space. Let's imagine that two vectors are coming from two different directions and striking on a point available in space. Both of them will have a particular angle on which they strike on the given point P. That means they are applying some force on point P. According to their angle, the resultant force will give moment to the given point P. It will have some effect on given point P. So we can define any plane or volume in 3D space. Here we can see there is a plane shown on a floor where it has some lengths given on x and y direction. If it is a simple plane, two axes are enough to represent it in mathematical form. So on y axis it is moving to 1, on x axis it is moving to 2. So x is equal to 2 and y is equal to 1 in this case. Now let us discuss addition of vectors. Vectors may be moving in particular direction. So we can refer this sign as representation of direction. Say top one is going to north, its opposite bottom is going to south, right side is east, left side is west. So if we consider two vectors, in this case we are considering force as a vector. If we talk about the electromagnetic wave have two components. One is electric field component and another one is magnetic field component. When we say that we have less mobile signal, then we have less components of electric and magnetic field intensity. When we say that coverage is good or mobile network is good, that means strength of electric and magnetic field is more. And definition of electric field intensity is nothing but force per charge available in that particular space. So force is a vector quantity. Force is important quantity to calculate the strength of electric and magnetic field in space. So for example, if we have two forces working in same direction, if they are moving in same direction, in this case both of them are moving in east direction, then they will be directly added and the magnitude will increase. In another case, if two vectors are moving in opposite direction, one is of positive 120 newtons, another one is coming in opposite direction, its magnitude is minus 18 newton. In that case, they will get subtracted and the resultant will go in the direction of the largest force. So the final direction of the resultant force will be less. It will be 120 minus 80, 40 newton, and the direction will be towards east. Similarly, if two vectors are moving in opposite direction to each other and one is positive, another one is negative, then the resultant will be 120 minus 200, that is minus 80 newtons. The higher force is going towards west, so resultant vector will also move towards west direction. Now if a force is coming down towards south and another force is going towards north, both of them are coming in each other's direction, then in this case both of them will have a resultant direction toward the largest one, that is going towards the north. Now let us see examples where we can find out the magnitude of a vector. Here we will consider that there are two vectors. One vector is going towards east, another vector is going towards north. Now let us take one example. Here we have to find out magnitude of a vector A it is given by 3i plus 4j. That means this vector A is going in two directions, I and j. I is nothing but x direction and j is nothing but y direction. That means it is moving in x and y direction. So, A is moving in x direction 3 places, say this is 3, and moving in y direction with 4 places, say this is 4. So, this is 3 and say this is 4, and the resultant will be the hypotenuse. So, how we will find out the magnitude? We will find out the magnitude of vector A, where mod of A is the magnitude. It is given by square root of ax square plus ay square, where ax is 3 and ay is 4. So, to find out it, we will get square root of 3 square plus 4 square. It will give us root of 9 plus 16. It will be root 25, and a value of a will be 5. So, if my x component is 3, y component is 4, then the resultant will be 5. Same we can get with the use of Pythagorean rule. Like this, we can find out the magnitude by taking square root of all involved directions. Now, we may have vectors moving in different directions. So, according to that, we can use the addition and subtractions of the vectors. In similar way, you can find out the subtraction of two vectors. Now let us check out dot products. We will see two methods for finding out dot products. In this example, we have to find out dot product of two vectors, and the two vectors are given as a is equal to 3i plus 4j and b is equal to 5i plus 2j. So, this component will be ax, this one will be ay, this one will be bx, and this one will be by. So, a can be written in the form of iax plus jay cap. So, magnitude into direction. Similarly, b can be written in the form of I plus j. So, dot product of these two will be taken with the direction components, where I square will become 1. So, ax cap into bx cap plus ay cap into by cap. Ax is 3, bx is 5, so it will be product of 3 and 5. Ay is 4 and by is 2. So, if we solve it, we will get dot product as 7. This is one method of finding out dot product. Then another method. These dot products can be given along with a angle. Suppose one vector is moving and it is having magnitude of 8, and another vector have magnitude of 15. So, this is the resultant. Resultant is given at hypotenuse. Along with that, angle is given, angle is 30 degrees. So, to find out the vector, we have to use the formula a dot b is equal to mod of a dot mod of b to cos theta. This is the formula alternatively used to calculate the dot product, where mod of a is 8 and mod of b is 15. The angle between two is given as 30 degrees. So, a dot b will be 15 into 8 cos of 30. So, if we solve it, we will get 15 into 8 120. Cos of 30 is square root of 3 by 2. If we further solve it, we will get 60 into square root of 30. Square root of 3. So, if we further solve it, we will get a value around 104. Like this also we can find out the dot product. If two vectors are perpendicular to each other, that means if their angle is 80 degrees, if their angle is 90 degrees, then what we will do? We will consider cos theta as 90 and cos 90 is nothing but 0. So, in this case, the dot product of perpendicular vectors will become 0. Similarly, if we take dot product of an angle which is larger than 90 degree, then we will get answer in negative. Now, if we multiply a vector with scalar quantity, so say my vector A is multiplied with another scalar quantity, then the magnitude of this vector will increase and the direction will be same as of earlier vector. If vector A is multiplied by negative scalar, then magnitude will increase but the direction of a vector will change. So, if earlier vector was moving towards right side, then after multiplication with negative scalar, it will move towards left side. Similarly, we can find out cross product. In next session, we will discuss about the cross product examples and curl, which are another important parameters in the subject of electromagnetic fields.